Hello everyone, welcome to this training on AWS. So AWS basically provides a massive collection of cloud services that form the backbone of modern data engineering pipelines. It allows engineers to build scalable, resilient, and cost-effective solutions for ingesting, storing, and transforming and analyzing data. So basically, apart from data engineering, there are also other services that are uh, suitable for AWS, or AWS can be used to build other applications apart from data engineering. But our focus is data engineering. Okay, so if we want to break down of how AWS basically fits into major phases of data engineering lifecycle. So basically for data ingestion, we have Kinesis, which is a real-time ingestion for streaming data. It is like the conveyor belt that moves things directly from the source to the storage area. Then we have AWS DMS, which is database migration service. This is basically used for moving and replicating data from on-prem or other cloud databases like relational or NoSQL into AWS storage. It is like a moving truck which is used to transfer large databases securely. And then we have S3, which is basically a simple storage service. I mean, we often use the final landing zone for both batch and stream data before processing, and this can be this can be referred to as it's like the main receiving dock where all the data is first dropped off. Okay, and then the second category is for data storage, where basically your data sits or where your data lives. So normally data engineers need different storage options for different needs, whether it's raw data, structured data, data warehouse. So AWS has multiple services, like S3 is again can be used for data storage as well. So basically the data lake, for the purpose of data lake, it can be used. It stores vast amounts of raw, unstructured or structured data at a very cheap and durable cost. It's like a massive warehouse that holds every piece of data regardless of its shape or size. Then we have Amazon RDS or Aurora, used for operational relational databases, often as a source or destination for transform data. And this can be referred to as the organized filing cabinet for structured or transactional data. And then we have Amazon Redshift, then MySQL or SQL Server database. So these are basically the cloud databases or data warehouse optimized for complex analytical queries on highly structured data. Okay, and this is like the high performance research library where data is neatly organized for rapid analysis. Now, once the data is ingested, stored, then we have the processing and transformation. So basically the ELT or ETL engine. So this is the core engineering part, cleaning the data, enriching it, and restructuring the data. So for this we have AWS Glue. So Glue basically is a serverless ETL service that runs Spark jobs, handles schema discovery and job scheduling. And then this acts as the assembly line of or assembly line and robot workers that clean, reshape, and transform the raw material, which is basically data. Okay, and then we have AWS Lambda. This is a running lightweight event-driven code for micro ETL tasks, such as triggering a job when a file lands in S3. Okay, and then this can be, uh, we can uh, understand this like, it's like the quick response queue that handles small immediate tasks. Okay, And then finally we have this data cataloging and accessing the data, so finding and querying the data. So for this we have AWS Glue data catalog. So this acts as a, I mean, this basically is the central metadata repository for all data in the data lake, which is S3. It stores the schema in a certain structure of the data. And then we have AWS Athena, which is a serverless query engine that allows users to run SQL queries directly on data in S3 using Glue Catalog. So, in summary, AWS is a comprehensive toolkit that empowers data engineers to manage the full data lifecycle, moving from raw, messy data to clean, actionable insights, all while leveraging the benefits of cloud scalability and pay as you go pricing. Getting started with AWS console is no different than any other application. So basically, you'll get some credits to look at all the services, or the services that we will be doing for this particular session is or the credits that you'll be getting after you do your initial configuration, or like after you take the initial trial version, will be sufficient enough for for the current project demo. So basically, you have to get started with the AWS dot Amazon dot com/console. So now once you're here, so you have to use this option sign into console. But since if you'll be using it for the very first time, then you have to create an account. So if you go ahead and hit create an account, so basically, just like any other services, you set it up and set up the form, and then you can start creating your account. Okay, so as you can see, like if you're using it for the very first time, you have to set up your account. You have to provide your email ID. Then you have to verify email address, and then you'll get a form. You have to fill up that form, and then it'll ask you for your credit card. So you have to fill up your credit card details, and at the start you'll get like $100 of credit, which is sufficient for uh, for most of the services. Okay, there are some services where you will need a pay as you go license, like for example Dynamo database, Kinesis, you will need pay as you go, or you have to upgrade yourself to pay as you go. But that's the reason I have tried to avoid using those services. So basically, uh, we will be using Dynamo database for this particular demo. Okay, now since I have already created an account, so I will not be needing this one. So basically, once I have created my AWS account, so I'll just go in and use sign into the console. Once I sign into the console, you can sign in using your account ID. If you are remembering your account ID, but normally, like what I like to do is I sign in using root email or root user email. So I can go to root user email. So basically, you can set up your account ID, IAM name, and password, and then you can go in. But I'll also show you how we can set that up. Okay. Okay. Now, this is where we can set up or where we can log in. So basically, I'll be providing my email address and then the password. So now we are into um, we are into AWS. So now if you can see, since I've already used it or I've already created some of the services, so now you can see this is how it looks. So basically you'll get all these widgets. If you want to add a particular widget, you can also do that using this option like favorites, managed instances, summarization, or path compliance. Any of these widgets, if you want, you can add. But yeah, or else if you want to reset it to default layout, you can always do that. Now coming back to the services, you'll see a list of recently used services. You'll see a list of recently used services. But yeah, if you're doing it for the first time, you may not see this option. But yes, as you start using it, you'll keep getting this one. Apart from that, this will be your account ID. Like for example, this is my account ID. And then if you want to be specific for a particular region, you can select which region you want. Okay. Since this is a default one, I'll continue with the default one. And since I have developed the codes and everything using this particular region, so I will go ahead with this region. Okay. Now, apart from that, if you want, or if you are already aware of a particular service, like for example, IAM. Okay, if I'm hitting IAM, so identity access management. So basically, I can directly go to a particular service if I want, or else if you are not sure which service you want, you can always go and click on the services option where the services have been categorized using this option. Like for example, for analytics, you have Athena, AWS Clean Rooms, Cloud Search, all these options. For cloud or application integration, you have all these services. For blockchain, business application, for different services, you can see there are different categories available. If you want to go by category or if you want to explore, you can always do that. Okay. Now, you also have this option like this is like a settings option where you can get console home where you get applications and all services as well. Okay. Now, the very first service that we will be looking at, or which is relevant for the current or the current demo, is basically IAS. So IAM. Sorry. So if I'm searching for IAM, so this is how I can go into the IAM service. So let me just go into the IAM service. Okay, there we go. Let's first try to understand what is IAM. So IAM is or identity and access management is a service that controls who can access what resources in your AWS account. It's all about securing access management. Okay, and in IAM you have these specific options or which are very important. There are also other options like account settings, root access management, but these are, I mean, I mean, if I want to go, I can keep going on IAM and it will take like I can take an 8 hour session of IAM, but that is not our goal. So we have to, start at some point and end at some point. So for today's demo, so we will be using users, roles, and policies. Okay, so I'll walk you through on what is users, roles, and policies because these are the things we'll be using. Okay, now let's talk about users. So what are users basically? Users is this is an entity that represents a person or application that interacts with AWS, and it uses a username and password to sign in and perform actions. And then, as an individual, I mean, it could be like an individual employee with a unique ID or badge. Okay. Now, if you want to create a user, you can always go ahead. Let me duplicate this. Okay, let me show you how to create a user and how to set up the access key and security key. Okay, so if I go ahead and create a user, I can hit this option, create user. So these are some of the users I already have. So we will be using this particular user, demo users 3v1. But let me show you how we can create users. Okay, so I can go ahead and hit this option, create user. Okay, I will provide a username. For example, I'll provide a username as um, E to E. v1. Okay, end-to-end v1. Now once I have that, I hit next. Okay, now it'll ask me whether I want to create some policies. I'll talk about policies and role in a while. So basically by default, you can just, add user to a group. So you can leave it as default and then you hit next. We can always add policies at a later stage as well. Okay. Now, like for example, if I go back, I want this particular user to access all the S3 buckets, okay, or all the storage buckets. So in that particular scenario, I'll use attach policies directly, and then under policies, I will type S3. Okay, now you see a policy. So these are some of the default policies that are available, but you can also create your own policy. Okay, you can customize your own policy. So now I have S3, so I select S3 full access, and then I can just go ahead and hit next. Okay, so now this particular user will have access to all the S3 buckets. Okay, now if you want to edit the policy, you can always edit it. So for example, if I take a look at the full access, take a look at the full access, and then I want to edit the policies, I can also edit it. Like for example, I can edit it through the JSON script. Okay, I can provide the exact resource or exact bucket which I want to provide access. We will come to that. And or else if I want to go with it as a default option, I can always go with it. Okay, now yeah, for this demo I just wanted to show something else. So here, so basically for this permission I have given like Amazon S3 full access, and then I hit create user. Once the user is created, so this is the user that has been created, so E2E V1. Okay, now I hit this I click on this one, E2E V1. Now once I have the user, it's not the end of the world. Once I have created a user, I can always add more permissions. Like for example, I have full access to S3, but I want access to some other services. I can also do that. Like I go here, I attach policy, and then I can use maybe Lambda. Okay, I search for Lambda, and you see all the Lambda related function, Lambda related policies will be available. So basically, I can select this one, full access, full Lambda access, and then I hit next. Okay, add permission. So now my permission, my uh, user will have access to both S3 and Lambda full access as well. Okay, so this way you can add as many policies as you want. Okay. Now, whenever you're creating a policy, you access the policy through, there are multiple ways of accessing it. So access, y- normally you access the policy through access keys. Okay. Now, here you see, you can generate the access keys using this particular option here. So what I'll do, I'll just go ahead and hit this create access key. Now, I can generate the access key through command line interface. I can download it as a local file. I can, like third party service, and there are multiple ways of doing it. So for today's demo, I'll use this local code, and then uh, I'll confirm, check this confirmation, and then I'll hit next. Okay, and then create access key. So once I created the access key, okay, so basically I'll hit done, continue. Okay, so now my access key has been created. Okay. Um, Okay. Now, once the access key has been created, basically you can keep the access key as it is, or you can deactivate the access key as well. So, if for some reason you don't remember the access key, or you have deactivated, you can always create your access key again. Okay. Like for example, I did not download the password. So basically, what I'll do, I'll deactivate this access key. I'll create a new access key now. Okay. Okay, so I'll create access key, local code, tag value, I'll mention it as test v1. Okay, create access key, and you see the access key got created. Earlier, for some reason, it was not created. That maybe I did not tag it. That's why that could be a reason it was not created. But yeah, since I've created a tag in the previous step, so that now the access key has been created. So basically, if you want to use the access key and secret access key, so this is how you do it. So basically, this will be my access key and this will be my secret access key. So don't worry about using this access key, because any which ways after this demo, I'll be deleting it. Okay. Um, Now, once you've done that, if you want to store your access key, you can always download this file. So basically, I have downloaded this particular file. If I don't remember the access keys and I want to use it, I can always use this particular access key. Okay, so now I can hit done, and now I'm good to go. Okay, so now I have created my identity access management, my access keys. So I mean, for today's demo, basically I'll be going with users. Okay, now this is the user that I'll be using. Demo users v1. Okay, so now if I click on this demo users v1, so now you can see, so these are the policies that I have assigned it to. Okay, Amazon. So let me just show you so that you can capture, or if you want to uh, uh, if you want to do it along with me, you can do that. Okay, now Amazon DynamoDB full access. This is the um, access, or these are the access, or these are the services I have provided. So how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 services, and then I've created one more. Uh, it's a custom policy that I've created. So if you want to take a look at the custom policy, okay, so this is the custom policy. So for DynamoDB, it's read and write, and for S3, it is list, read and write. Okay, so and if you take a look at the JSON file, this is the JSON file. I'll copy the JSON file and store it along the description of this particular video, so you can access it. Okay. Okay, there we go. Um, Now, once I've created the users and then the policy, so let's go ahead and talk about roles. Okay, so what are basically roles or role? So role is basically like it's an identity that you can assume to gain temporary permissions, not permanently associated with one person. Okay. Like it also grants temporary permissions to AWS services depending on what policies you are assigning to that particular role. Now, grants, I mean, as I said, so basically using roles, users in another account or federated users. Uh, Sorry. Yeah, as I was saying, so basically it grants temporary permissions to AWS services, users in another account, or federated users. And if to give you an analogy, so basically it is like a shared security guard uniform that anyone can, or anyone with permission can put on to access restricted areas for a specific task. Okay, now. Sorry. So basically, just like we are creating users, roles are also have a similar approach. So basically, if you want to create a role, so you can hit create role, Now, what are the different types of roles? So if you want, I mean, if you want your role to have access to AWS services, so you set this by default, or else if you want your role to be custom, so you can always use custom trust policy where you can update the JSON depending your needs, and then you can go about it. Okay, but for today we'll be use AWS service because we'll not be using role any which ways. I mean, we will be using at one point, but I'll come to that. Okay, now whenever we are creating a role based on AWS service, so it will ask you, I mean, I like to call it as a base service, but I mean, normally in AWS environment, it is called as a service or use case. So use case is basically like, what is the base service you want your role to be created. Like, for example, if I'm creating a role which is based around Lambda, or maybe I want to create a role which is based around maybe Glue. But in my Glue, since Glue is used for ETL, it is extracting data from S3 bucket. So basically, my at a later stage after creating a role, I can add another policy where it has full access to S3, or maybe it has full access to DynamoDB. Okay, something like that. Okay, now to create a use case, so basically, like for example, if I want my role to be having access to something, maybe I'll start off with Glue. Now I select Glue, and then that's it. So basically, I'll hit next. And then what are the other policies that I want access? So by default, it will have access to Glue. Apart from that, maybe I'll just go ahead and use S3. Okay, full access to S3. Now I hit next. Okay, role name I'll let test role demo one. Okay, and now since I have provided access, this is the trust policy that I will get. And if I want to edit it, I can always edit it. So the policies and all, you can look at it. Okay, since this is the default one, so I'll get like this. But after creating the role, the trust policy will change a bit. Okay, so the role has been created. So now let's go back and look at the role. Okay, okay, so I created the role test role demo one. Okay, so now so S3 full access, so trust relationships. Okay, okay, so now you can see the S3 full access. It has permissions for S3 full access. And again, if you want to attach policies, again you can come here and attach policies. Okay. Now, the role that I will be using in this particular demo is called glue-based IAM-DD. So if you take a look at the role, so this I'll be using while creating a Glue database. So now it has access to these policies. Okay, all of these are not required. So basically, these are the policies or major policies that you'll be needing access. Okay, not all of this. S3 full access, AWS Glue Console full access, and AWS Service Notebook and Service Rule. So these are the four. So these four are most important. So you can provide access to these four policies. Okay, for this particular rule. Okay, once your role is ready, we will be using role at certain point, but remember the name of the role is basically it's called glue base IAM-DB. Okay, so now coming back to policies, there we go. So this is where I know you can create policies. So suppose by default, if you want to create a custom policy, you can always go ahead, hit create policy, and then visually you can create, like for example, I want to create a policy for S3. Okay, and I want to have access to all S3, or maybe specific or I want to provide specific access level like access list access grant, or or list jobs. If I want to provide, I can also do that. Okay, if I want to just give read access to a particular to a particular action, then I can always customize and do that. So basically I can do either allow or deny. Like basically if you're selecting deny, it means you're denying this access, and if you're selecting allow, basically it means you're allowing that access. Okay. Now, apart from that, so basically you can always go ahead and select the JSON script as well. Like if you select JSON script, and this is how you can edit your policy directly through the JSON script. Okay. Now, let me show you some of the policies that or custom policies that I have created earlier. Okay, so this is one of the custom policies that had created glue create session. So if you take a look at this, now, let me look at another policy which we will be actually using it. Okay, it's called DynamoDB. DynamoDB to S3. Okay, if I set JSON, so this is the policy. So what it does basically, uh, it will what it allows object creation for S3, list bucket for S3, delete object for S3, and put object for S3. So the resource basically it's using this particular S3 bucket. Okay, these two S3 buckets it will be using, and everything within these two buckets. Okay. Now, what else it will allow? It will also allow within DynamoDB create table, describe table, list tables, put items into the tables, write batch items and get items. Okay, and it will have access to this particular table in DynamoDB. So this is the table that we'll be using, and this is the bucket that we'll be using. It's called my AWS bucket EYV1, and the Dynamo database that we'll be using is log table. Okay. Now, coming to policies. So basically, I mean, if I talk about policy, so policy is like a document that formally defines the permissions. It specifies what actions are allowed or denied on which resources, basically, and it is also is it is attached to users, groups, or roles to grant or restrict access. So basically, to give you an analogy, so these are basically a set of rules written on a badge, whether like if you want to open a door, I mean open door A, door B for a particular user, and then not open door C, something like that. Okay. Now, coming back to our use case, or for this particular demo, we'll be using demo users 3v1 for today's demo, and then it has these policies. I have already created the access keys, and then these are the policies that it will have. The next service we'll be talking about is AWS S3, or as we call it, I mean, we call it S3, like which is simple storage service bucket. Okay, so to get into S3, so basically we can just go in, type in S3, and then we are into, I mean, we click on this one, we are into S3 service. Okay, yeah, there we go. So yeah, so Amazon S3 is basically an object storage service offering industry-leading scalability, data availability, security, and performance. So bucket is basically a container for data stored in S3. So S3 object storage is flat, not a file system hierarchy, but you can organize objects using prefixes like just like you create folders. So folder like paths, you can create folder like paths within buckets as well. Okay. Now You can also provide rule like bucket names. I mean, there are some rules basically whenever you're creating bucket names. So bucket names should be globally unique across all AWS service. Okay. Now, um, within the buckets, we have objects. So the fundamental entity stored in S3 is an object which consists of data itself and metadata like type, size, and date. Okay. Now objects are retrieved using a unique key or name within that particular bucket. Okay. And if you talk about use cases, what we'll be doing is basically we will be storing data. I mean, we will have source files, okay, which will have information about customers and um, orders. So basically, we'll combine customers and orders, and then after combining it, we will store it in the destination. From destination, we will be using it for other purpose. Okay. Now, let me show you how to create a bucket. Okay. Now, once you are into Amazon S3 service, so basically you can hit this create bucket option. Okay, now the bucket that I'll be creating is for general purpose. I'll maintain it. I'll provide a bucket name. Okay, and yeah, so this is the bucket name. Next, we will go and ACLs disabled will maintain as it is the default option. Then we will uncheck this block all public access. Okay, and if you want it to maintain public access, you can do that, but yeah, for today's demo we don't need it, so we will uncheck block all public access. And then I will use I acknowledge the current settings might result in this bucket objects becoming public, so that's fine with me. And then bucket versioning, I'll if you want to enable the bucket versioning, you can enable it. For now, I'll keep it as default, and that's it. We can maintain everything as default, and then we can just go ahead and create the bucket. Okay. 1 second. Okay, the name has already taken, so that's why we are getting an error. So we will take something else. So test bucket. I will use V103, something like this. Okay, just to create a unique name. Okay, there we go. Our bucket is created. Okay, so now our bucket is created. So basically, if I want to access the bucket, I can go to Amazon S3 um, and then so I click on general purpose buckets, and then this is where we can get list of all the buckets. So recently I've created this test bucket 1947V1903. So if I click on this one, and basically the region you can select. If you want your bucket to be sitting in a different region, you can always change this one and then create a bucket so that you know your bucket is in a separate location, or in a specific location that you want. So within this particular bucket, if I want to create folder, I'll go ahead and create folder. So basically I will create a folder. I will call it as test source. Okay, and then I can create another folder or as many folders as you want. So basically, I'll call it as test destination. Okay, so basically, you can maintain one level of hierarchy, or if else you want to maintain multiple levels of hierarchy, you can always do that. So in our test source, basically, if I want to upload a file, it's fairly straightforward and simple. So basically, I'll hit this upload option, and then I can add files. So from my local folder, I can just go ahead and add files. So basically, I'll add, I'll just add something. Okay, I'm adding two files, customers and orders and customers. So once I've uploaded or once I've added the file, I can just go ahead and hit upload. So basically it will upload. All right. So now both my files are available. So now if I go back, close this, I go back. So to buckets, and then I use test bucket 1947v1903. So now in my source, I'm having orders and customers. Okay, so these are the two files that I've uploaded. Okay, now for this particular demo, okay, I'll be using since I have already prepared the code for it, and we want to do it in a limited time. So basically, I will be using. Let me confirm. Sorry. My AWS bucket BUCK Bucky V1. Okay, so this is the one we'll be using. My AWS Bucky. Okay, so let's take a look at this particular bucket. So basically, what it has is it has a source folder where I'm placing orders and customers, and then it has a destination folder where it has, since I was trying, so I'll delete this one. So basically to delete a file, I can click on this and use this delete option. And then I can use permanently delete. Okay. Now if I go back, so I don't have anything. So basically I have two folders. Let me see, what is this? Okay, I don't want this. Maybe something got created. I will clean this up. Okay, so now we have in my S3 bucket, which is called MYAWS Bucky V1. So this particular bucket, I have two folders, source and destination. In my source folders, I have two files, customers and orders, and in my destination, I don't have anything. Okay, it's blank. So I'll be using these two files. I'll merge these two files, okay, using a primary key that is customer ID from orders and ID from customers. So I'll merge these two files. And then I'll create one final file, and in that final file, I'll dump that final file in the destination folder. Okay. Now, let me walk you through the architecture, like how I'll be designing the flow. Okay, okay. Let me explain you. How we are designing the entire process. So what we have done, so we have these S3 buckets. Okay, we will have these S3 buckets. Okay, now in the S3 buckets, we will have orders and customers. Okay, now we will have a Python script which will, I mean, this S3 bucket is basically the source folder. We can maintain it in different folders, but yeah, just for accessibility, I've maintained it in source folder. So this Python script basically will import the data, or I'll not say import. This will just read the data, orders and customers. It will merge them and then finally dump it in destination folder. Destination folder. Okay. Now, so it will be called as uh, managed orders and customer. Okay. Now both the files will be will remain in S3. Right. Now, what will happen when we are importing the Pythons in the Python script itself? We have created steps to for generating log information, and the log information will be collected. Log information will be collected in the log table, which is DynamoDB. Okay, log information will be collected in DynamoDB, and this Python script. I mean, we can run it locally, but why to run it locally, right? So I don't want that dependency where the Python script to be ran locally. So I will host this particular Python script in Lambda. Okay. So just to understand, we have a source. We have two source files which will be merged using a Python script, and then the final file will be dumped in destination folder, and then the log files will be collected using DynamoDB, and the entire Python script will be executed through AWS Lambda. So this will be our architecture of the entire flow. Hi everyone. So the next service we'll be discussing after S3 is AWS Dynamo. Okay, now to get started with AWS Dynamo, I can just type in Dynamo. Okay, so it gets you, or it gets us to DynamoDB. Okay, now DynamoDB is basically a fully managed serverless NoSQL database that delivers single-digit millisecond performance at virtually any scale. Okay, and this is a key value and document based database, and I mean the tables are basically collection of items, and if you talk about items are basically a collection of attributes similar to a row in a relational database, and then we have attributes which are a fundamental data element similar to a column. Okay, then we also have primary key used to uniquely identify each item in a table. Like the primary key in a SQL table, it can be a partition key simple primary key or a composite key like a primary key plus a sort key. Okay, and it also has the ability to scale horizontally and maintain consistent low latency performance even with massive data loads. Okay, now, for this or for today's demo, we will be using, first let me show you how we can create a database. So basically, you have to maintain a particular region that you where you want your service to be created, and then once you are there, you can always go to the tables option, and once you are in the tables option, you can create a table. Okay, so for this particular demo, I have created a log table, but let me also show you how I have created a log table. So I have created a table. I'll hit this create table option. I'll create log table. I'll call it as log table v1. Okay, and then a partition key, I'll use log id as my partition key. Okay, and then if you have or if you want to create a sort column, which is optional, you can create one. Otherwise, that is not compulsory. So without sort column also you can live. Okay, so once you have your table created, and yeah, for now I'll just let me just just create this table. If I hit create table option, it'll take it'll take a couple of minutes and then the table will be created. Okay, so since I've already created a log table, let me just show you how we can go about, how we can query it. So if I go to my log table. Okay, so now this is my table detail. Like I have a log ID, the capacity mode is on demand, the table status is active as of now. There are 12 items in this particular table. Okay, now if I want to query, so I can use this party QL editor. Okay, so if I do a select star from log table and then I hit run. Okay, so now I'll have this information. Okay, log ID, message, and then timestamp. Okay, so basically just like you're querying any regular SQL, you're using SQL queries. It is little different from that. So I'm not going into how to query using particle, but yes, for some basic querying, adding filters, you can always use where and then where clause and then query it. Okay, like for example, if I just want to copy this. Okay, and then if I go back and run it, I think it's not identifying it properly, but yes, just like you have to play around how it works. Log ID. Okay, so yeah, so you can just play around like how the query works and all. I'll not go detail into it, but yes, from your end, you can just give it a try. Let me just give it a try for the last time. Yeah, okay, yeah, so I have to single quote. So log ID, so this is my log ID. Okay, so this is how we can query and look into log details. Okay, now next feature is basically we'll look at AWS Glue and Crawler. Okay, now if I type in AWS Glue. Okay, now AWS Glue is basically a serverless data integration service that makes it easy to discover and prepare, discover, prepare, and combine data for analytics. Then it's also helpful for machine learning and also application development. Okay, now AWS Glue is basically like it has the the central component of extraction, transform, load operations. It manages the entire ETL workflow, and you also get data catalog, which is the persistent metadata store that holds definitions and locations of your data. It is the central index for all your data. And you can also have ETL jobs. These are basically Python or PySpark codes that performs the data transformations. Glue runs these jobs on a serverless Apache Spark environment, basically. And apart from that, AWS Glue crawlers are basically a program that connects to a data source, especially like an S3 bucket or DynamoDB table, determines its schema and populates the Glue catalog. And this process basically it's called crawlings, or it crawls through the data files, infers the data types, and then creates or updates a table definition in the data catalog. Okay, so you can think of it as, an automated data inspector that figures out what your data looks like, and then it builds I mean, depending on what your backend or your S3 data has, it will connect to it and build a schema on top of it. Okay, now for example, um, so if I go to database. Okay, so first I can go ahead and create a database. I'll add a database. I will call this database at my test db v1. Okay, and location is fine. I don't want to give any location as of now. Then I just go ahead and create a database. Okay, so my database got created. Now within that particular database, I'll create a table. Now I can create a table manually, or else I can just use one of the S3 files and use that as a reference and create a table on top of it. Okay, like for example, I'll use this add tables using crawler. Okay, now once I do that, so basically I can provide the crawler name. I will call it as my test p1. Okay, and I'll hit next. I'll add a data source. So yes, yeah, so we have to select the data source configuration. I can go ahead and add a data source. Like for example, if I hit on this add a data source, basically I can select whatever service I want. I can select DynamoDB S3. So from whatever service I want, I can just create a data source on top of it. Like for example, if I go to S3 and after using S3, there are no connections available as of now. I mean, this is any which is optional. So basically, I go to an S3 a path. So I browse. Okay, and then I can pick up whatever table I want. So, like for example, I want to create a table on my final file. I mean, after combining orders, and I'm just going back to the our source problem. So basically, we are combining orders and customers files or tables, and then we are dumping it into destination. Okay, so I will just go ahead and use or pick up destination. And remember, if we are using crawlers, these are also dynamic in nature. Like so, for example, if there are files with different file structure, so they'll also combine them and create one single table with all the columns. Okay, now we can select the select which folder I want as my table. I can select the folder and then I can hit choose. Okay, once I have done that, and then I can just go ahead and add an S3 data, and then I can hit or I can select this data source as S3 and then I hit next. Now, this is where I have to use the IAM role. So earlier, if you refer my video, so basically I have selected this particular, I mean, I was discussing a particular IAM role. So basically I can use that. Okay. I can use this uh, test role V2. Okay. And then I hit next and I'll choose the database which I want. And then I hit next and then I create the crawler. Okay. Now I have to wait for it for the crawler to be created and the crawler to be up and running. So I'll just go ahead and hit this run crawler option. Okay. So the crawler is starting successfully. So we'll have to wait for a while. Okay, so by the time this runs, let me walk you through the code that I'll be using. Okay, now, so first I'm importing these packages, pandas, Boto3, uh, IO from string IO, Boto core exceptions, client error, UID and date time. Okay. Now I'm creating variables, access key, secret key, bucket name, destination key, region, and DynamoDB table. So the log table. Okay. So in the next step, I am going to create uh, S3. S3 and DynamoDB clients. So basically, okay. So first I'm defining the S3 variable. Okay. Uh, in this S3 variable, uh, defining S3 variable, and then I'm next I'm defining DynamoDB variable where I'm defining or passing the secret access keys for DynamoDB as well, and then I'm creating another variable for log table, so which is DynamoDB log table. Okay, now let's understand this particular part. Say log to DynamoDB, this particular message. So this function is dedicated. Just bring Okay, this function is a dedicated logging mechanism. It requires a unique identifier log ID and using UUID and .UUID4. Okay, it also captures the current UTC timestamp using timestamp, and then it attempts to write an item to specified DynamoDB table, and it also contains the unique ID, the timestamp, and the log message. Okay. Then if we come to read underscore CSV S3, so basically this function extracts data from S3 and converts it into a pandas data frame. It logs the start of the reading operation. It calls s3.object and to retrieve the files contained from a specified S3 key. The binary data object body dot read is coded in a string dot decode UTF-8. A string IO object is used to treat the string data as a file in memory, which is then passed to pd dot read underscore CSV. Okay, it logs the completion of the reading operation, including the number of rows read. It returns the resulting pandas data frame. Okay, and next is basically so we have inserted another function just like before this function basically handles the necessary cleanup before writing the new data, okay, in the destination folder. So this function it logs the intention to delete the file at the destination key. It calls s3.delete object. It handles a specific client error, then no such key, and which simply means the file doesn't exist, then no problem. logging that no file was found. Okay, and any other error during deletion is logged and the exception is re-raised to stop the script. Okay, now next next is basically this upload to S3 function writes the final merge data back to S3. This function it logs the start of the upload. It calls S3 dot put underscore object, passing the files contained, which is basically the data parameter as the body, and it logs the successful completion of the upload. Okay. Now, next part is the execution flow. So now let's come to the execution flow. Okay, so this is where the execution starts. So the main part of this particular script orchestrates the entire process within a try and accept block to ensure robust error handling and logging. Okay, now what we have here is in the start. First, we are using log to DynamoDB, so which is like this is particularly taking the script execution started. This is the log that it will start. Okay, next we have is we'll just clean up or delete. So this delete S3 file, this particular function removes the old merged file if it exists, and then we have this extraction or read step, which basically where we are using, you know, orders is equal to read CSV from S3. This reads the orders data and then it reads the customers data. Okay, and then we have the transformation or the merge. So log to DynamoDB. So this is basically this is just a log which says starting that merge, and then we have the merge table that we're creating, orders dot merge. Then we are creating or defining the join, and then we are again using a log, that is log to Dynamo. So data merged successfully, and then we are just defining or presenting the rows. Okay. Now, then the preparation for load. So here we are creating a variable CSV underscore buffer, and we are here. We are passing the string IO function. So this creates an in-memory buffer to hold the CSV content without writing to the local file system, and then merge to CSV writes the merged data frame into the buffer. Okay, and then we are using the upload to S3. So this particular function uploads the content to the buffer to the final destination in S3. Okay, and then I've created an accept block to, just in case files are not present, it will give us script failed error. Okay, and then the final step is log to DynamoDB function, which basically helps us script execution completed successfully. So that particular message. Okay, so now if I would like to execute this particular Python code, so basically I can go ahead and first I have to go to my root location, and then I can just go ahead and execute using Python sample underscore project dot py. So if I execute, so now you see the execution has started, and then it is also so there is a deprecation warning, but yeah, that's fine. We can, replace that. You can replace it with some other function. Okay, so now the execution has successfully completed. So now if we go back to our AWS. Okay, so since we started our crawler, so let's go back to our database. Okay, and in this particular database, let's first go to S3 bucket. So I'll just duplicate this. Okay, so now if you take a look at our S3 bucket, um, general purpose bucket. So we'll go to our particular S3 bucket, let it load. So we'll go to Bucky V1, and I'll also create a duplicate just for DynamoDB. Okay, so this is our S3 bucket that we have been using. So if I pick this and then I go to destination, you see the file got created. So this is my system time, 1905 UTC. So exactly at this time, the destination file got created. Okay. So now if I go to DynamoDB to look at my log files, I have used or I have used this particular table, log table. Okay. So now if I just go ahead and query, select star from log table. Okay. So this is the date. So on 3rd 10 2025. So this is the time. So these are the logs that got created. Okay. Now sorting and all, I can do a sorting on timestamp. So yes, so now you can see this is the log that got created, the log files. Okay. Now, next we'll go to databases. Now, remember, I did not create a table. I just create a crawler which points to a particular folder. So it points to this particular folder, destination folder, right? Now, I even did not define the schema of that particular table. But since within this particular table, I have defined a crawler. Okay, so just to go back to crawler. So this is the crawler that I have defined, which is basically pointing to our table. Okay, so test crawler. So I just created now. Okay, yeah. So this is the crawler that I created right just now. Okay, so if we take a look at it, so this crawler, this crawler is basically pointing to this particular table, and then I've pointed it to a particular folder in of a particular S3 bucket. Okay, now if I go to my database and then I see what are the tables that are available, I'll just refresh. It'll take some time just to populate since the crawler is still running. I mean, it is not completed. Okay, it has completed now. Okay. So now the crawler that earlier when we created the crawler, it was pointing to a destination folder, but at that time, no file was present. So that's why we are not getting that table. So now what happens? Now, if you see in my destination table, a file is present. Okay. So now I just go ahead and run the crawler again. Okay. So I'm completing or I'm running the crawler again. So depending on your, so if you depending on your needs, you can even schedule your crawler. Like if you know at a certain point of time new files come in, you can always come to schedule and set up like when you want to schedule your crawler, or when you want to run your crawler, you can also schedule that. Okay. Now if I go to back to my databases, take like some time. Let me just take a pause here. Okay, so now you can see the crawler has started. I mean, it has detected the table, and now you can see the table has been created. So the table, since the table was in a folder which was called destination, that's why I picked up the name. But you can always customize that. It's completely up to you. Okay, how you're defining it in crawler. So since I've not defined the table name, so that's why it's just picking up the default folder name. Okay, so either way, you can create a custom folder name so that it picks that folder name as a table, or else if you want to customize the table name, you can also do that. Okay. Now my table is created. Now what next? Okay. So if you want to view the table data, okay. So now if you want to view the table data, you can always view the table data. But now there is another service which can help you to view the data catalog database tables. Okay. Now that particular service is called Athena. So now, so let's go to Athena. Now, if we talk about Athena, so Athena is an interactive query service. Okay. So yeah, so by the time it loads, so Athena is basically an interactive query service that makes it easy to analyze data directly in Amazon S3 using standard SQL. Okay, and it is basically a serverless service, meaning there is no infrastructure needed to manage it. You simply have to define the schema in the Glue data catalog and run a SQL query against your data in S3. Okay. Now, billing is basically like you pay only for the queries you run based on the amount of data scanned, and sorry, and Athena also uses schema information from AWS Glue Catalog to understand the structure of data files, whether it's JSON, CSV, Parquet in S3, and then it executes the query. Okay, so just like any SQL query, you can use any queries you want. So, okay, so just like select star from destination. If I go ahead and uh, run again, okay, so now this is the table that I have, all the columns. ID, order ID. So ID and ID X and Y has been created, and then order date, name, segment, state, city, all the details have been clubbed together in one single table. Okay. So once you have your query, so now this is how basically we can automate the entire process, but there is still a bottleneck. The Python script that we have used, it is being uh, executed locally on my machine. Okay, so the multiple ways of doing it, either you can set up uh, a microservice to execute the Python script. You can use Kubernetes as well. But within AWS, there is a very popular service called AWS Lambda, which can be used to execute the Python service. So basically, you can use, we have to tweak the service a bit. Tweak the Python code a bit, and then we can execute the Python code using AWS Lambda. So we will be discussing about AWS Lambda in our next video. So guys, please subscribe, follow, and I'd say please do like, subscribe, and follow. Okay. Thank you. Thank you so much for watching this video. Thank you.